Last class we discussed about vertical deflection system. Today we can see about horizontal deflection system. We know that for CRO we are having a two deflection plates. I mean two deflection system. One is a horizontal. Another one is a vertical deflection system. Previously we discussed about a vertical deflection system. We can see about what is called a horizontal deflection system. The horizontal deflection actually consisting of time base generator and an output amplifier. Here in horizontal deflection system, how the horizontal deflection wave will be generated. We can see about how the horizontal sweep generator or a horizontal wave will be generated. We can see how it will be generated. Already I told the class there is a two essential point to have a time-based generator, or for the wave which is used for a time-based generator, that it must have two qualities or two important points. One, the waveform has to be increased linearly, and then second point, it has to, once it reaches the maximum point, suddenly it has to return to zero. These 2 points has to be satisfied by only the sawtooth wave. So let's take other waves. Let us take a sinusoidal. It is not a linearly increasing, so we can't able to use sine wave. Let us take a square wave. It rises suddenly, therefore it is not linearly increasing. And then third one, let's take a triangular wave. Linearly increasing, the first point will be satisfied, but it is decreasing linearly. So the second point will not be satisfied. Let's take a sawtooth wave. It increasing linearly. First point will be satisfied, and then the second point, once it reaches the maximum point, it has to return to zero suddenly. Why it has to return to zero? Once the first, it has to trace the signal, then after tracing that, it has to return to zero position. Therefore it has to return to zero immediately. That will be satisfied by the sawtooth wave. This will be used for horizontal wave generation. Okay, let's see how the horizontal wave will be generated in a horizontal deflection system. Let us see the circuit diagram. Sweep or time-based generator. Okay, here this circuit practically consisting of RT, that means timing resistor, CT, timing capacitor. Here you are having a UJT. We know that UJT consisting of two terminals, that is a base. This one is a B1, B2. This one is a emitter. Here you are having a resistor R1 and R2. This is a output. There we are having a output will be generated. Actually it is not exactly the sawtooth. It is not actually the exact sawtooth will be like this one, but practically the sawtooth will be somewhat like this one. Okay, we can see how the sawtooth will be generated. A continuous sweep or a sawtooth waveform of a time-based generator is shown in the diagram here. The UJT is used to generate the sawtooth wave. The UJT is used to generate a sawtooth wave. Initially the UJT is off state. The capacitor CT is charged through RT in exponential manner. Initially the capacitor will not contact. The UJT will not contact. That is in off state. The capacitor CT, this one, the capacitor CT is charged through the resistor. Initially, once again I am repeating, initially the UJT is in off state. Due to the VBB, that is a given voltage, the capacitor CT is get charged through RT, I mean timing resistor. Let me see that. Then since the capacitor CT is exponentially charging, the same potential rise is taken as the output V0. Here CT is charging. This output terminal is parallel with this capacitor. So once the CT is exponentially, this one is exponentially charging, the same voltage will be existing in the output. Therefore we can get this waveform. Okay. Then now the V0 rises, the exponentially, and the emitter voltage VE also rises. Here this terminal is not only connected to the output. Wherever the capacitor rises exponentially, the same output will be generated here. At the same time, the emitter is also connected through this one. This voltage, the emitter to base 2 potential will also increasing. What happen? As soon as the VE reaches the peak voltage, the emitter to base junction at the diode is forward bias, thus the UJT is fired and triggered. What happens? The same voltage, the rising potential, this one is existing across the output. At the same time, this voltage is also existing across the B2 emitter junction. Therefore, once that reaches the threshold limit of the gate, the UJT gets fired or triggered. This switch will closed. Once the UJT is fired or triggered means the switch will be closed. It means the UJT is on state. This will provide a low resistance path for the charged capacitor and also VBB. Once the switch is closed means what happened? The current will flow through this way. At the same time, the voltage across the capacitor, the charged capacitor here, the charged capacitor in this capacitor, that will be drained through this junction. So the voltage will not appear in the output, because comparing the impedance or the resistance of the output side is lower than that of the output. The resistance of the output side is higher than that of this UJT. This resistance, this junction resistance is comparatively lower than that of this output. Therefore the entire voltage is drop across this, or the entire current will flow through this junction. So what happened? The capacitor is suddenly discharges. It means the UJT is on. This will provide low resistance path for the charged capacitor and also VBB. Thus V0 decays up to the minimum of VE in that it cycles repeat. Therefore UJT2 goes to off state. Once the entire capacity is discharged, again there is no any voltage or current to flow through the junction, then the UJT is again switched off. Okay. So what happens? Again the cycle starts. The CT charge exponentially and V0 rises exponentially. Thus the on and off state of the UJT repeats continuously to form a sawtooth wave. To improve the linearity, to two separate input voltages, what is called a linearity improvement. Here is the practical case, the waveform is like this one. So what exactly we are in need of means that it must be like this one. So to improve the linearity, what we have to do? To improve the linearity, two separate input voltages has to be provided. One is a low voltage supply to UJT, high voltage supply to RT. This is a high voltage supply for RT and CT, and then low input signal. So this will increase the linearity. The linearity of the output waveform. By changing the value of RT and CT, we can change the frequency. By changing the value of RT and CT, the frequency will be changed. By changing the value of CT, the step change is frequently obtained. The continuous or sawtooth change in the particular range is obtained by varying the RT. The input signal is used as a synchronizing pulse input. Thus the input signal frequency is synchronized and locked on the screen. Okay. So Once again I am repeating, very simple to understand how the horizontal deflection system is working, how the sawtooth wave is generated. That is consisting of, we have to memorize the three important points. One is UJT, another one is charging resistance, another one is charging capacitor. Okay, initially the capacitor is in off state. Now the capacitor is charging. Okay, exponentially charging. The same capacitor voltage is existing across the output side. So once it is charging, the exponential wave is generated. Okay, once it reaches the same voltages across the base 2 and emitter junction. Once the voltage reaches the maximum value, this junction gets short circuited, that it provides a low resistance path. Instead of the voltage exists across the output, the entire voltage goes through this way, the current flows through this way. Though suddenly the voltage drop will occur, suddenly all the stored potential in the capacitor is discharged. So it comes to zero. The cycles repeats. The on and off position of the UJT has to produce the sawtooth wave. Then the linearity will be improved by providing a separate voltage, high voltage and low voltage signal. Okay, and then frequency will be changed by this one RT and CT. That's all. Okay, thank you.